In this video, we want to talk about the polynomials and degree. Okay, so let's remember a polynomial is simply a function of the form a(n) x to the n plus a(n minus 1) x to the n minus 1 plus plus all the way down to a1x to the 1, but we usually get rid of the 1, and then a0 x to the 0, that's a0. So the a's are the constants, these are the coefficients. Each a is a coefficient, and we have a bunch of different coefficients. And then we have the powers, and then the variable is x. So these are the coefficients. This last coefficient is usually called the constant term. It's just a number. So the a's are numbers, the x's are variables, and then we have the powers associated to each x. Let's look at some examples. And so you might have just something like this that you've seen probably many times in your classes before. So here's 3x squared plus 2x plus 1. That's a polynomial. In this case, the first coefficient, the a sub 2, because it's associated to the power 2, is 3. Here the coefficient is, which is a1 because it's associated to the power 1, x to the first, is 2, and then the last, the constant term, is 1. This is a sub 0. Okay, those are the coefficients. Now, there's this highest power, so we have the power 2, the power 1, and if you like, the power 0, because x to the 0 is 1. This highest power is called the degree. So this is a degree 2 polynomial. Okay, another example. We could write 5x to the fifth minus 2x to the third plus 1/2 x, and that would be a polynomial 2. In this case, the constant term is missing. It's actually implicit. There's a 0 there, but we usually don't write it. The constant term is 0. Also, we don't have an x to the fourth term, and we don't have an x squared term. Here we only have like odd powers of x. The coefficients are, well, this is the a5, a sub 5, this is a sub 3, this is a sub 1. Those are our coefficients. And the degree of this polynomial is the highest possible power, which is, in this case, 5. So here, this white polynomial is degree 2 polynomial. This blue one is a degree 5. Again, the degree is simply the highest power that appears in the expression. So for example, for a degree 2 polynomial, the highest power that appears is 2. For a degree 5 polynomial, the highest power that appears is 5. So let's look at another example. So now I could write something like this. Here's a polynomial. I'll write it as a function. F of x is 2x plus 3x squared minus 2 plus x to the sixth. Okay, so what is the degree of this polynomial? Well, I've kind of mixed things up a little bit. It's not necessarily the first term, although often it is. It's the one with the highest power. So the degree is actually, the highest power is 6. So this is degree 6 polynomial. Okay. What is the leading coefficient? What is the coefficient associated to the highest power, the degree 6? Well, there's an implicit 1 here. So actually a sub 6, that's the leading coefficient, the one with the biggest power, that's equal to 1. We have 1 times x to the 6th. So that's, what's the constant term? The constant term is here, it's minus 2. So what's important here is to look at the why do we care about the highest degree, the x to the 6th, is simply because f of x grows like x to the 6th. If I were to, let's look at it differently. Let's put everything in order. So the first term I'll have is x to the 6th, and then I'll have the next highest term is 3x squared, the next one is 2x, and then minus 2. So this is the same as it was before, but now everything is in order. Well, if x is very large, implies that f of x is very close to simply x to the 6th. Because if x is a very large number, and I take that number to, say, raise it to the 6th power, suppose x is like 10, then I get 10 to the 6th, which is huge. If I only take 10 to 10 squared, or a very large number squared, that's huge too, but nowhere near as huge as x to the 6th. So what's important about the leading term and the degree of the polynomial is that for very large x, the leading term tells you, gives you an approximation of f of x. So for very large x, f of x is approximately x to the 6th. This stuff is just small change. Okay, so this was an introduction to polynomials and degree.